Okay, I'm going to talk about adding IPv6 to Cloud Foundry and how we want to go about that. So first, a bit of an introduction about myself and the scenario, the motivation, a couple of potential solutions and their potential issues, our plan and status of where we are right now, and then the next steps to be addressed, closing with a conclusion that hopefully will start the discussion. So, intro and motivation. I'm Alex. I am coordinating the IPv6 activities in the Cloud Foundry core area of SAP. We have more and more customers that want IPv6 support. Many of them are governments, not only the US government, but also European governments will want some support 2030, around that. So the earlier we start, the better. And one kind of big asterisk is I can only speak of how we at SAP use Cloud Foundry, which is mostly CF on virtual machines, so not Carifi, with Bosch. And we use it as a multi-tenancy platform as a service system, where some of our internal lines of business run stuff, but also external customers run stuff. And we need to keep them apart. But it's not isolation groups or something like that. All right, in this talk, I want to outline our goals, ideas, wishes. Basically, it would be nice if, and we will have to do this before long. And we hope, of course, that the community will help us with that and that we can start a stream of work here towards IPv6. And maybe also important, not all of the things that I'm showing today are equally feasible, useful, and whatever you want to call them. Some of them are wishes, some of them are seeds for ideas, and together we can talk about them. Most importantly, we see this as a great opportunity to fix some of the things that are just inherently bad with how IPv4 works, because it has a limited address space, that it has a preference for private IP addresses, and so on. And also ideally getting rid of all of the port remappings that we have now, being able to address workloads more directly, because we have so many addresses now that we can basically address each individual stone of sand on a beach, pretty much, right? But we also need to see that IPv4 will stick around, because we will definitely have customers that will need v4 capabilities. And where we go with Cloud Foundry then depends on all of our needs. All right. So quick refresher of how the request flow, which is the most important bit that touches IPv6 somehow in Cloud Foundry works. We have the client, we have a load balancer. Some of us have HA proxies. We use HA proxies. You don't have to. You can go directly to GoRouter. And then GoRouter talks to the Diego cells. There is a Silk container network interface, I think, CI, that manages all of those ports. And basically, each of the applications that exposes a port is then remapped to a port on a Diego cell. You see that this might be limiting if you have a lot of Diego cells. So the black lines, black arrows are the Ingress. The blue arrows are Egress. I think CF was not necessarily designed for a lot of egress, because it's web applications, you have request response, fantastic. We have workflow engines, we have other orchestrator things where the app itself does a lot of calls. And then the NAT gateway can be limiting, which actually is going to be what I'm explaining next. If we wanted to do the absolute bare minimum to allow communication for ingress and egress with IPv6, first and most important, it checks the feature flag. Yes, we do v6, fantastic, great. We would basically terminate IPv6 at the load balancer, in worst case at the HA proxy, depending on the hyperscaler. And for the egress, we could use a proxy, a SOC 5 proxy, for example, where the app then needs to be configured to actually use that proxy, and then there's some DNS magic. It's also not something we actually want, so I'm not going into too much detail about that. And it's not something that just exists, that you can just deploy, and it works. The bit about the proxy is, of course, that each of the apps needs to be aware of this proxy, that it exists. And with that, you need to change apps. People don't like changing apps. Some limitations that we see with IPv6, there's a couple of those slides. So first with Diego, the port remapping that I was just showing. And because SAP is not using the app-to-app communication for various reasons, including some large address tables and so on, but also because there's no load balancing or not good load balancing, the requests that go out from the app and talk to another instance of the app are actually going through the NAT gateway and then through the load balancer. And what does the load balancer see? It sees the NAT gateway's IP address. If you don't have a NAT gateway, you see the Diego cell's IP address. You don't actually see which workload, which container it came from. And for analyzing logs from a deployment or an environment that has how many? 50,000 different customers and hundreds of thousands of apps, you might want to know who is actually causing a lot of traffic. The CNI, there is resource exhaustion issues, but I think most importantly for us, why we don't use Silk and the app-to-app communication is that it doesn't do load balancing well enough. Nevertheless, it's still another piece of the puzzle that we might want to avoid, if possible somehow. And finally, the NAT gateway, again. At some point, there's also resource exhaustion, because you can have only so many open connections with the tuple of client IP address and target IP address. And if you have 3 or 5 NAT gateways and you have 1 or 3 load balancers, at some point, the ports run out. And again, if you have 100,000 apps that have a bunch of connections, you will do that sooner than later. And I think we have on the biggest landscape now 27 NAT gateways to avoid that, and that's a lot. And each of them costs money, right? So we would really like to avoid NAT. This is our vision of how we would like to have it. Dual stack just for the practicality of it. Sorry, it's so much text. I'm going to go through it though, so bear with me. The Ingress part is actually pretty simple. It's something we can figure out pretty easily. Most importantly, there is also, on all of the hyperscalers, there is stuff for that already. And you basically just need IPv4 and IPv6 listeners, at the very least on the load balancer, maybe also on the first line of DHA proxy or Go router, whatever you're using. And that helps you retain the client IP address, which we are interested in. IPv6 Egress is then the thing where, in this presentation, I'm going a bit more crazy, and this is the wish that I would like to have. And this is per container IP addresses. So each of the containers that you deploy on Diego would actually get its own separate IP address, IPv6 IP address, of course, without the need to remap the port to a Diego cell's port and so on. And with that, you can also just address it directly. And the thing on the right that you see with the DNS-based resolution, for Diego, that could mean that you might have an app that resolves to a DNS name that has all of the IPv6 addresses of the app instances of that particular app that maybe span multiple Diego cells. And that would allow listing, block listing, all of those things that our users would like to do, but at the moment can't. Might also help with load balancing later on. This is things that are the kind of not the most well thought out yet, but the things that we should work on, I think. All right, how can we do that? You can just assign a /a decider, for example, to the Diego cell, and the Diego cell can then pick out addresses from that CIDR range. With that, you can also put all of the Diego cells in consecutive CIDRs. So if you need to allow list your complete CF environment, you can also do that with one CIDR. At the moment, we also have the problem that we have 27 different IP addresses for the NAT gateways, and we would like to avoid that. And last but not least, all of the things that we know and love about CF, like security groups, about all of the communication flows and the control, should remain as is, not necessarily with the same code, but conceptually the same. Right. So this brings us to the practical solution, as I call it, because this is probably where we're going to end up anyway, because we will need v4 support, and we can add IPv6 support and experiment with that before we then maybe pull the trigger for the next thing that I'm going to get to. There's, of course, some drawbacks. If you have to maintain different networking stacks, it's more work because you have all of the things that IPv4 does, plus all of the things that IPv6 will be doing. But it might be a good transitioning mechanism because we know that the v4 stuff works as is, and we can use this opportunity to try out and do all of the cool things with v6 to get it proper, to leverage it to the most extent possible, and avoid the nut stuff. And again, the IP addresses per container would then allow for an egress that is just very clean and very clear. Also, if you go back to the Ingress side, you know exactly where it's from. This is then the next step in a pure IPv6 solution, so to say. So internally, we just go with IPv6, and IPv4 is just something we terminate on the Ingress and Egress layer. So basically, the exact opposite of the first version that I was showing. That would mean the most changes, because, OK, I'll get to that in a bit. Right now, we don't really support IPv6 internally. But there is a thing called 646 XLAT. 464. From IPv4 to IPv6, back to IPv4, meaning that you can have a purely IPv4 client talk to a purely IPv6 landscape. And there's a bunch of translation at the network level. And that is all standardized as part of the IPv6 standards and works. It could also, if each of those instances has its own IP address, allow container-to-container communication without having a CNI, potentially. Of course, you need still security groups, firewall rules, and so on. But that might simplify things. One thing we see as a risk here is that the operational experience with IPv6 in the industry overall, and SAP in particular, is not great yet. So there will still need to be a bunch of things to be learned, best practices to be gathered, and things to be built up. And the migration path from a v4 only to a v6 only is probably going to be the dual stack thing in the middle. Unless you have some better ideas, of course. All right, plan and status. For the Ingress, so this is why I'm saying I don't have a full solution yet. We're at the very beginning of this. We're now experimenting with enabling Ingress with dual stack on AWS. I can tell you in person if you want to know why AWS specifically. So we're developing all of those things. There will be a testing phase that will also extend to other lines of business that actually use Cloud Foundry later on, and then eventually we'll deploy it to all the customers. For Egress, we're still in the research phase, and we need to align with the community, so with the people here, and on Slack, and wherever you are watching, to identify options, limitations, workarounds, and so on. So there's a lot of things that I gloss over and say, oh, this is how we could do it, but there's a lot of technical things that still need to be solved. And we would really like your ideas, contributions, feedback on how we could approach those, or where you see maybe other risks that we haven't considered yet. Next steps. As I said before, IPv6 support in Cloud Foundry is not very far along. This is a screenshot from the documentation, which basically says if you want v6, let your load balancer do it, and do v4, and don't worry about it. I think this is not what we could do, what we should do. Some particular things, there is, I think, support for the vSphere CPI. On the other CPIs, I have not, so because we're mostly running on hyperscalers, I have not seen any v6 support, and I'm not sure how the v6 vSphere support is, but again, we're not using vSphere. The stem cells, as far as I know, have v6 disabled on kernel level. It can be re-enabled. Georgi has done that. It's just a few sysctl calls, and you can re-enable it. There's no problem. But ideally, we would have some flag or a stem cell or whatever that is v6 enabled. And for the other components, we haven't, because we're at the beginning, we haven't checked in extreme detail yet. But there's probably some things that need to be adjusted. Some of them might be very minor, some of them might be pretty major. The good news is, though, that all of the language runtimes that we use, be it Ruby, be it Go, internally we also use some Python, but that's a different story. They're all IPv6 capable, so the foundation is there. We just need to get the code, our code, to do it right. Also, top right, Cunningham's law, if anything that I say is wrong, it's on purpose to elicit the correct response. And finally, for the hyperscalers, there's always some things that are a bit weird. For AWS specifically, for example, you can't get a load balancer at the moment to do dual stack that passes through a dual stack. It's either talking to your backend in v4 or in v6. And to get the other address, you need to use proxy protocol. Another thing is that it doesn't use unique local addresses. So these are like the, as far as I know, Georgi, if you correct me if I'm wrong. Yeah, it's a plus, it's a plus. It's just that things are different. And it's actually good, so the ULAs are a good thing that it doesn't support it, because this actually, so unique local addresses are like the 10 dot whatever, I don't know the RFC, are internal addresses. They tend to overlap if you have multiple deployments that you just deploy with the defaults. We have this problem with v4 at SAP. And if you just use publicly routable addresses and you just block them with a firewall that they don't get traffic, you don't have any overlaps. It guarantees that you don't have overlaps. So that's the recommended way from us anyway, to not use unique local addresses, which actually brings us to Azure, where you only get unique local addresses. We're talking to all of the hyperscalers, slowly but steadily, to also realign some of the things, because ultimately, we want a solution that has as little as possible divergence between the different hyperscalers. You see some other things here as well. Everybody does it slightly different. And Terraform does it slightly different. So it's still a long way to go, but we're actively working on it. To conclude, you've heard our point of view, and we would like to hear yours. We think that IPv6 is a topic that we can't ignore. It will come or has come to you already in the form of, at the very least, governments. So it will need to happen. We'll need to go through all of the components and check. We're starting to do that now with the Ingress to see if things break, if suddenly you get an IPv6 address somewhere in the X404 header or some other parts. At some point, we'll enable Egress and try that as well. Yeah. The other part of my story is that we would really like to use IPv6 to the fullest extent possible, meaning per container IP addresses, trying to check and rethink whether we need the CNI and whether we can avoid it, and generally to avoid port remappings, network address translation, and all of those things as much as possible. And finally, we're at the very beginning, as you've seen in this Gantt chart, quote unquote. So we've shown you some of the ideas that we could do, and we would really like your feedback now to see where you see issues, whether you would be interested to contribute, whether you're on board with this, whether you think it's a great idea, or I'm just talking nonsense here. Please do that today in person. I'm around all day. In the Slack channel, I've taken the liberty to create CF IPv6 on Slack, so please join me there. And then, of course, we'll have direct discussions with the respective teams and component leads, and eventually RFCs. I'll leave it on this slide, and I'm open for questions, comments, feedback.
V6 or bust?
Indeed, I don't have really a question, but it's a large piece of work, and on the Bosch side, yes, there are a lot of places where things need to evolve a little bit, but that's great.
Yes.
That's actually a project moving forward.
Yes.
And the yeah, I want to say really, it's great to improve Cloud Foundry in this way and make it IPv6 compatible with those improvements for larger scale.
Yeah. I was mostly happy to hear that we as an organization actually want to not do the bare minimum, but we want to do more with IPv6. And as a technical person, that's just, yeah, it's nice. It's nice to hear. It makes me hopeful. And I think it will be a great contribution that we can make here and a great collaboration.
So to start making baby steps towards this, what is in the way or what needs to be done in order to at least just turn on the support in the noble stem cells, for example?
So there's a few sysctl controls that are disabling IPv6, addresses, forwarding, all of those things. We have, if you want, Georgi over there can tell you exactly which ones they are. I don't remember by heart, but it's like 7 or 8 properties that you need to flip from off to on, and then it works. That you can have an IP address on this Bosch VM assigned. Then, of course, you need Bosch to know which IP address ranges to use, how to assign them, and so on. But the stem cell itself is just enabling the Linux sysctl flags.